Good afternoon to everyone who's joining us. In terms of timing, we'll be starting the webinar in about 5 minutes. 5 minutes time, we'll get started. Good afternoon to everyone who's joined us this afternoon. We'll be starting the webinar in around about 2 to 3 minutes. Good afternoon. We are nearly at time. I can see the numbers are still going up in terms of the participants, so I'll give it a couple of more moments and then we'll get started with the webinar. Okay, we've reached just past the hour, so I think we'll make a start. Thank you very much for taking the time to join us on what is the fifth in the series of webinars that we're running in association with CBSE. They started in September. We'll talk a little bit about the previous sessions and the ones that are coming up in the course of the webinar later on. But it's great to have you with us. And I'd like to just start by thanking CBSE, in particular Dr. Saha and Mr. R.P. Singh, for really for the opportunity to work with them on delivering this series of teacher training sessions. So let me move on to the agenda for today. We'll start with a quick introduction to the ARM School program. For those of you who have joined previous sessions, you're hopefully familiar with how we work. For those of you who are new to the webinar series, I'll describe a little bit about the background to the school program and how what support we can offer you besides these sessions in terms of teaching and learning resources and professional development. We'll then move on to the main training session run by my colleague, Rob Lehman. That will last, this will be in the region of an hour, pretty much an hour, so about 59 minutes, 58 minutes. We'll then move on to feedback. I'll pass over to my colleague, Surya, who will say a few words about the feedback form for the session. We'll then have a Q&A session. So we'll respond to any queries that you have or questions that you have about the subject matter over the course of the session. And then we'll finish off with session closure. So just on the point of Q&A, if you have any questions throughout the session, please do put them in the Q&A box, and my colleague Surya will help facilitate answering them where she can, or sort of bank them for the Q&A session at the end of the webinar. Additional points which often come up in previous sessions: the certificates for attendance will be emailed to you, so you will get those after the session, along with a link to the slide deck and the recording of the session. So all of those things will be provided to you after the session. So you don't need to worry about the details of certification. That will be sent through to you directly. So I think we should let us move on and get started with the introduction to the school program. Okay, so here we are. The speakers for today. The main session will be run by my colleague Rob. This is a particularly exciting session, I think, for us. Assessment of PBL is something that is often seen as a real challenge for teachers who are carrying out project-based learning in their lessons. And Rob's background and experience in curriculum development and assessment has puts him in a great position to be able to speak with some authority on the matter. So he's been involved in curriculum and assessment development in the UK and internationally before joining the Armed School Program a few years ago. So there's a lot of cumulative experience and expertise that he'll be sharing with you over the course of the hour of training. Myself, my background is in educational product and, development and assessment. So I've worked internationally across the Middle East, the Americas, and the UK in developing resources, principally around the STEM subjects for primary and secondary schools over about 15 years before joining ARM. And the ARM School Program was set up just a few years ago. We started in 2018, and our vision really is to, as you can see here, is to empower all learners with the opportunity to develop the interest, knowledge, and skills that enable a lifetime of engagement in STEAM. And our motivation for doing this is there's multiple factors to it, really. I suppose there is a big factor is the pervasiveness of ARM's technology in all connected devices that people would use typically within the course of a normal day: mobile phones, laptops, even products like fridges now will include IoT elements to them, and those will be quite often ARM-based. So I think the fact that ARM's architecture is a foundational technology means that we take very seriously our stake in supporting learners who are moving through their education possibly into a career with ARM or with the companies that we work with, and we do work with a very large range of different organizations. But also thinking about empowering people as citizens of a world where it's becoming increasingly important to have an understanding of how technology works, how issues such as handling of personal data affect you, to empower you really to have the skills to make informed decisions and choices about such matters. So I think there is a broader societal interest there in really helping everyone get to a point where they can constructively engage with a world that is quickly changing as a result of technological development. And so how the school program works, we're part of a larger education team that covers everything from primary up to into universities and research as well, to some extent. We work principally through teaching communities of practice. So we support groups of teachers who are supporting each other really in their own professional development. We do this through creating content and training to some extent. Some of this is done with our partners, such as Microbit, Raspberry Pi, Arduino, some of the big organizations that we would work alongside. And we create professional development such as this webinar. There's also our courses on edX.org, which are free to access. We also create curriculum-linked teaching and learner resources, and this would include lesson plans, worksheets, videos, presentation material. The videos you can also view on YouTube. So you can find out all about the resources that we offer, and they're all free of charge if you visit school.arm.com. I'll walk you through a little bit on that on our website in a second. I think one point just to raise at this stage is that the examples that we give throughout the presentations, this session and also the previous four, are drawn from the projects that you can find on our website. Again, they're free to download. You can explore them in your own time. So I would really encourage you to do that. If there are aspects of what we're discussing today that you find you'd like to explore in more detail, it's certainly worth downloading some of those materials and giving the projects a go. And here is the site. this is what it looks like. You can see in the boxes there at the bottom, you have there are a range of, and that does extend downwards when you visit the web page. There are a range of different resources that you can access depending on which physical computing device you would use. And there is a brochure that describes what we do, really, what we offer as a program to help you and your colleagues as professional teachers. And there it is. This is what the brochure looks like. I think it really does touch on all aspects of the school program, all the way from the pedagogical approach that we advocate for, all the way through to the materials that we offer to support teachers who are interested in exploring it. So as well as downloading the brochure, you can also sign up to our newsletter to get regular updates. We send a newsletter about once a term, and that gives you updates on the latest activities from the school program and the latest resources that you can access, as well as some updates from our partners. So plenty of news to share on a termly basis. So all of the webinars in this series with CBSE are really draw on themes that are covered within our edX professional development program for teachers, and that's called Teaching with Physical Computing. There are 4 courses within Teaching with Physical Computing. They cover the whole range of issues connected with delivering project-based learning through the use of physical computing devices. So these are small programmable devices, relatively inexpensive, that would be typically used within a classroom scenario. Things like the microbit, devices from organizations such as Raspberry Pi and Arduino. So if in the course of viewing these webinars, whether you're doing it on catch up or whether you're watching them in real time, there are aspects of this of the webinars that you would like to explore further. We very much encourage you to search for the program. So search for project-based learning on edX.org and sign up for free. It's free access, and you can follow the course in your own time. Now, today's webinar very much draws on course 3, as you might expect, assessment of project-based learning. So if you want to explore these themes further, please do. You can start at course 3. That could be a good place to begin your journey with that program. So, as I mentioned earlier, we are in the 5th session of the webinars with CBSE. We started back in September. The previous 4 sessions, which you can see listed here, are all available to view, and you can find links to them on the web page where you signed up for this webinar. So if you go back there, you should find that there are links there that will take you to the recordings of those sessions if you'd like to catch up on them. The next ones that are coming up, next one, which comes in March, is developing employability skills with project-based learning physical computing. That's something that obviously as a technology organization, where the talent pipeline into ARM and the organizations that we work with is something that is vitally important to us and the wider technology industry. So I think that will be a very interesting session to look at how the STEM skills that we seek to engender through project-based learning relate to the kind of skills that we would hope learners will start to develop for application within the modern workplace. And we'll finish off in April with how to run an innovation day, and this is around how you and your colleagues can come together and organise a competition based around physical computing and solving real world problems with physical computing to really engage your learners in computing and engineering. Okay, so we'll now move on to the main training session. This will last about an hour. We will then, I'll then pass over to my colleague Surya, who'll say a few words about the feedback, which we'd love to get your feedback on each session. We analyze that after each one and try to make improvements on future ones. So please do share your thoughts. And then we'll cover a brief Q&A for any questions that have come up in the course of the session. I should say that in previous sessions we have had some comments about the quality of the image and the audio. I'd just like to mention at the top of this that that's principally it's a bandwidth issue. We've done all we can from our side to enable the presentation to run smoothly, but occasionally the quality does vary over the course of the session, depending on your connection. So if your connectivity is good, you should have no problems. But if you're experiencing challenges with it, please do bear with it, because often within a couple of minutes it's back to being fine. So yeah, just sit tight. So we will start this main session, and we'll then run into feedback and Q&A. Okay, Rob, over to you.
Hello and welcome to the ARMSCORE programme, Assessing Projects in Physical Computing. In today's session, we're going to look at how to use assessment tools and structures in assessing our physical computing projects as part of a project-based learning pedagogical approach. So let's get started. First, I want you to think for a second about, why do we assess our learners? Why do we put them through the stress and the experience of assessment, and why is it useful? So just have a think about that for a second. What is the benefit to the learner, and what is the benefit to the teacher in assessing their progress through the projects or through their learning? So why do we assess? It's really important to consider using the tools of assessment as a key part of our practice of teaching and learning. We need to focus on measuring what we do, measuring the efficacy of what we do, and using that to improve our delivery, and also deliver improving the impact of our delivery upon our learners. If we don't measure what students know and then what they know later, how can we demonstrate the impact upon the progress of our learners? And we can do this all through assessment and using various different tools to do that. It's really important to consider a reflective practice when thinking about assessment. It's not just linked to formal outcomes such as certification, but it's a really vital tool in improving our practice and improving the way that students learn and the way that they learn through our teaching. And we can assess this process and use that to improve our practice in a number of different ways, which we will explore during today's session. So why do we assess? We obviously want to be able to demonstrate that our learners are learning. We want to be able to show that they are progressing through the curriculum. We want to show that they are improving their understanding of our subject, and that our practice and our teaching methodology is effective. Ultimately, we want to shape their learning so that they can work their way through a curriculum and then pass their formal certification at the various junctures throughout their time in school, through their exams and the like, and less formal outcomes in internal assessment inside the school. But assessment can come in many different shapes and forms, and we'll explore a few of those things today. So let's just take a step back for a second and look again at this learning landscape of project-based learning, and just consider how all of the different elements of this can be measured and can be thought about through the lens of assessment. So we use these pedagogical tools, be they theoretical or practical, and through the sort of more philosophical and psychological tools across the bottom, and then we apply all of these different pedagogical tools in order to have an impact upon our learners and to ultimately see them progress through the curriculum. And we use these in different weights, as different weights and measures to impact the learning of our learners. But if we don't measure what we're doing and we don't assess how our students are developing, what's the point of changing our practice and using all of these different complicated tools if it doesn't have an outcome at the end which is positive for the learner? So just consider all of the things we're about to talk about in the rest of this session through the lens of we apply all these pedagogical tools as levers to make the assessment outcomes more effective. So we use these different teaching tools to prepare our learners to pass the types of assessment that we're going to give them, and we assess them in different ways so that we can be confident in our assessment of their abilities, of their knowledge, and of their understanding. And lots of these tools that we can see on the screen now are part pedagogical, part delivery, and some of them are assessment tools in and of themselves. So just keep that in the back of your mind as we're going through this and help this understand and unpack all the different concepts we'll encounter along the way. So let's think about assessment in a slightly different way. A student, if asked what an assessment was, would think of it in the classical sense, in that students are brought into an exam hall, they sit down in silence, they're given a paper with lots of questions on it, of which they work their way through over an hour or two. This then is then marked and they are given a grade at the end of it. And in project-based learning, we have to think a little bit differently in all of this. Not to say that we can't use formal assessment tools in project-based learning, and in fact project-based learning can be helpful in building resilience in our learners so that they pass formal assessments more effectively. But in how we assess the students as part of the project, we have to think of it as a two-way dialogue. These are fundamentally practical exercises, and students are working their way through these tasks and these challenges and applying their skills and knowledge in interesting and technical and hands-on ways. And to assess them, we need to be in dialogue with them. We have to observe what they're doing, we have to listen to what they're saying, and we can, if we conceive of the assessment as being this two-way dialogue through observation and communication, then this makes understanding how we can use assessment effectively in PBL much easier to understand. So let's take a step back and look at the big picture of assessment. And let's unpick this a little bit and explore the 4 different types of assessment and then consider how we can apply these in our project-based learning lessons. So the first one of the 2 ones we're going to focus on today is assessment for learning. So this is where learners can become informed about their own learning through iterative and reflective exercises. The second is an assessment of learning. So this is more of a judgment of what has been learnt, and I'm sure we can all think of examples of that. And then the next 2, which we shan't spend too much time today, but is useful for an awareness of the bigger picture assessment, is assessment for teaching. So for example, it informs the teacher of their impact of their teaching, and then correspondingly an assessment of teaching, so a judgment of that teacher's teaching. So for example, a lesson observation. So the for and the of are really, really important to differentiate here. One of them is a sort of an internal reflective exercise, so you can use this to look at your own practice and seek to gain insights and improvement from that. And then the other, the of, is a more of a formal judgment of what has been learnt or how that practice is and can be improved. So we're going to look at the first 2 here from the learner's perspective. How can the learner reflect on their own learning and seek to improve what they're doing through iterative practice, and then also how we can apply assessment of learning tools and practices so that we can seek to measure the impact of what the learners are learning. And this is where we need to also introduce these 2 technical assessment terms, sort of summative assessment and formative assessment. So the first one, summative assessment, is that classical approach that we mentioned earlier. It is an assessment which sort of summarizes and is at the end of a learning journey, and you think of it as a formal assessment like an exam. It's a measurement tool, a formal judgment of a learner's progress. And then on the opposite of that, which we've touched upon previously, is formative assessment. So this is more of an informal type of assessment used throughout a lesson or a curriculum as a sort of a touch point. It's a line in the sand where we can measure how students are progressing, what they're learning, have they learnt anything at all, but it doesn't have all of the baggage of a an assessment which is at the end of a lesson. It's measuring smaller bite-sized concepts. It's more for measuring progress rather than the sort of totality of a course or a curriculum. So there's two very different types of assessment there, and we're going to look at what these mean and the impact it will have on the learner. So just to re-emphasize this use of formative assessment as a reflective practice and how this impacts upon our teaching and learning. And I can't stress this enough. To make ourselves better practitioners as teachers, we should be constantly reflecting on our practice. And as I mentioned before, I think the third time you deliver a lesson or a project or a concept it will be much better than the very, very first time that you deliver a lesson or a concept. And the more that we deliver teaching practices, the better we become at them. And we do this through this reflective cycle where we teach or deliver a particular thing. We self-assess, be that formally or informally or just through reflection. We consider how our actions, our activities, the way we spoke, the way we engage with learners, the tone, the intonation, the pace that we deliver these things have affected our learners. And then we let that inform our practice. And a sure sign of a good practitioner is someone who can do teaching and learning, reflect upon how it was done, and then improve upon it the next time that they do it. And this is something that we need to be mindful of as teachers, but also we should be instilling into our learners so that they think like this as they're going through it. And a vital part of project-based learning is this iterative development cycle, where they will go through this reflective cycle of learning something, of solving a problem, self-assessing, and then working out how they can either solve that problem and how they can factor in that learning into their project. So let's dig a little bit more underneath the skin of some of these technical terms. So summative assessment. Now we've described this as being sort of a formal assessment methodology, but there's an awful lot of stuff that sits underneath this. A student or a teacher may consider these as being linked to some of these key terminologies, and students will be given a mark or a score or a grade. And marks are an interesting thing to unpick. What do they mean? What is a mark? You might think of a summative assessment as being a series of questions, and they are weighted with marks. Each has a corresponding value, and students can be awarded a mark for getting a question right in a particular way. And that seems very, very simple on the surface, insofar as there needs to be a way that a student can get a mark by providing an answer. But the way a student gives an answer, especially with open and free-form questions, can be quite tricky to unpick. And this is where the idea or the conception of a mark scheme becomes really, really important. And it's a description of how a student can be awarded a mark. And it will often give examples of typical expected answers from a student. And whilst this is really, really useful in a written exam, where there are only going to be a number of different ways of interpreting a question, when we're looking at project-based learning and students creating often digital artifacts and projects which solve real problems, that can make it a little bit trickier to work with. Similarly with scores, scores are very, very similar to marks, and they will often have cut scores as well. So a value of a score above a certain mark will be associated with a grade, and then these grades can have profound impact upon a student's outcome. For example, the difference between an A and an A star could mean a job or not a job, or progression to a new higher education or not a higher education. So these marks, these grades, these scores, these all have profound impacts, and so it's really, really important that we make sure that these are as detailed and as precise as they can be when we're applying them to assessments. And this is why some methods of assessment are more useful and more accurate than others. And especially with project-based learning, it can be quite tricky. For example, in maths, it's quite easy to assign a correct or an incorrect answer because the answer is finite. It is either a number or it isn't. Whilst in for example, in a project, there may be a success criteria about a artifact or a bit of code doing a particular thing, and it could be done in a number of different ways, and who's to say which is the correct way of doing things? So it's there needs to be some sort of scaffolding or schema around which we assess the different things that we're looking to assess, which is fair and equitable and is easily translated by whoever's marking or assessing the students, so that they're doing it in a consistent and fair way. So these are some of the things we need to think about with summative assessments. We need to have a lot of support for the people assessing the learners, so that these things are done fairly and are done as accurately as possible. And this is where we can introduce the idea of validity, and what makes an assessment valid. Is it assessing what we want it to assess, and is it working as an accurate measurement tool? And this is we'll look at this as some examples of this a bit later on. So formative assessment. So again, we touched upon this a little bit earlier on, and we're going to look at a couple of useful examples of this, which we see in project-based learning. So this is obviously the informal way of assessing students as they're going through their project, and a good example of that is peer assessment. So as part of our project, we may get the learners to assess each other or assess the other group's work, and this can be is often seen as a way of sort of saving the teacher's time, but it's actually a really useful exercise for the learners to go and see what other teams are doing, and which they might learn something from that, and then providing a grade or a mark or a score for that student based upon a particular type of rubric. And getting the rubric right can be very difficult. You can have these very complicated rubrics which are difficult to apply, or you can have them very simple, sort of 1s and 2s and 3s marks. And so differentiating between the different sort of grades within that rubric can be quite difficult, and so we need to be able to train students up, and so that they can apply the marks accurately. And in project-based learning as well, there's occasionally some competitive element, and so we don't want the students to be unfairly marking the other group's work, and this is where it's really useful to drill home the idea of sort of gracious professionalism, and that by unfairly marking another team's work won't lead to their team having an advantage, because the other teams will likewise be assessing them, and so they helped to pay these things forward and mark as accurately as you possibly can. But teaching students how to assess each other is really useful, because then they will then take that learning and apply it to their own learning, insofar as they will know how they're being assessed, and so then they can then use that to improve their practice and cater their outputs so that they will access the highest grade possible. And that's ultimately what we want our students to do. It's not about teaching them to pass a test, it's about applying assessment tools so that students can eke out every bit of learning that they can, and they become confident and resilient learners, and not necessarily teaching and learning to a specific outcome, which is can be a little bit abstract. Now, peer assessment is again a really useful tool, and as long as it's done fairly. Another really useful part of this is the self-assessment, and again, students can misuse this in a number of different ways. They can obviously be over-generous at times, and view their own work as superior to others, especially if you compare it to peer assessment. And again, self-assessment is useful if you can give them some sort of prompts or rubric of which to assess themselves, and give them some sort of criteria. And in the ArmScore program schema, we use the success criteria for both of these approaches. So for example, all students would be aware of what the success criteria is, and we would get them to self-assess to what extent they're meeting the success criteria. And that's all part of this iterative development program, which we've explained in previous sessions. And so they will be constantly doing this throughout their work. Whenever they develop a new feature of their artifact, they will be having to self-assess and determine whether they've met that success criteria or not. And likewise with peer assessment, they can be going around and seeing the other groups' work and assessing whether they have met it or not. And this can be a really useful exercise in developing communication and collaboration, because they may use this as an opportunity to go and give feedback to other groups and point out where they may want to improve their product. And so rather than this being competitive, it can be seen as really collaborative. And you can see some really good examples of this once students get used to the types of projects that you're giving them, and you can almost bake in a necessity to collaborate through limiting resources or giving different challenges to different teams, based upon ability or resources. So yes, there's some really interesting things you can do using formative assessments without it involving the teacher doing any work at all, other than providing them with the rubric to assess with. And that's not to say that these types of assessments should feed into any formal outcomes. They're just a useful tool to get students to reflect on their own practice, and it helps them learn, and it also helps them collaborate and communicate and really demonstrate citizenship inside your classroom, and helping each other learn. So let's have a look at some ways that we can do both summative and formative assessment in project-based learning. So for let's start with formative. So we mentioned about using peer and self-assessment. We can also assess them formally using iterative assessment points. So for example, we can get the students to reflect upon the success criteria, and you can go and interrogate the learners and say, to what extent have you met this particular success criteria? And you can get them to either write it down or talk through what they've done. You can ask an individual learner to explain what a particular piece of code or a particular solution is and how it works and why did they do it in that particular way. Get them to explain how their design related to their finished product. Get them to explain any problems that they encountered along the way. You could step through their code solution if you're using physical computing projects and get the different learners to explain different elements, and if there's a bug, get them to troubleshoot it in real time. And that's a really good tool to assess your learners' progress, because you can see the learning in action. And throughout doing this, it's useful to use open questioning. We'll talk a little bit more about that later on, but it's really useful to ask questions in a way that it makes learners give you long form answers and gets them to explain what certain things are. For example, saying, what does this bit of code do, and get them to explain it in as simpler terms as possible. And this also is really useful if you're not a computer science expert, because then the students can explain that code in a way that your non-specialist could understand. Another useful way to sort of enhance peer assessment is to use the project manager role. So for example, if you're doing group work, you would assign one of the students, and you might swap this role every now and again, sort of every 20 minutes or so. So you are now the project manager. Your job is to ensure that everybody is doing something which works towards the success criteria. And then as a teacher, you can come and interrogate the project manager and say, explain to me, report back what everyone is doing, explain to me, to what extent are they meeting the success criteria. And by giving this role towards students, you're going to make them more resilient. You're going to make them, it forces them to collaborate, it forces them to communicate effectively. And it can be quite challenging to students who are slightly more introverted, but it also brings out the best in students, because they need to look for successes, and it forces them to understand it without necessarily having to come up with the solution, but they need to understand it, and be able to explain that to a teacher, even in some simplistic terms. And that can be a useful way to assess progress, in the extent to which they can explain the solution. And that can be quite useful if you've got mixed ability groups, and if you're one of your students is like a real whiz with code, for example, and they're off doing a solution, their team will suffer if they can't communicate what their code does to the project manager, and that project manager can't relay that back to the teacher. So that again, it forces them to work with each other and communicate and work as a team. Also with summative assessment, you can bake in some of these more formal assessments into the process. You could use an MCQ quiz, and these are multiple choice questionnaires. And again, we'll look at this in a bit more detail shortly, but these are quite easy to do, because you can have banks of multiple choice questions related to the task in hand. You can link them to the success criteria, and students can answer them quickly at the end of a lesson. It might only take a few minutes. And the beauty of these is that because you're typically in certainly physical computing lessons, you're in computer labs, you'll have access to computers, and so you can automate the marking of these, which saves teachers an awful lot of time. And you can create these tools. There's lots and lots and lots of free applications which you can use to create multiple choice questionnaires and even long answer questions as well. But MCQs are a really useful way to do assessment and to get what you need for them in a semi-formal way. I mean, MCQs are used in formal assessments. There are formal exams which are only MCQ based, but they come with their own set of problems, which we'll dig into a bit later on. Long answer questions are an equally valid way of assessing these, but these are a little bit harder to mark, although it does give you a richer view into what the students know and what they understand. And you could frame these around the students explaining to what extent their artifact meets the success criteria. So get them, you could literally say to them, here's the success criteria, explain in your own words how you've met them, and that might include explaining the code, or it might include how they've interpreted the solution to a particular problem. So using the success criteria as a tool for assessment is really, really important in project-based learning. And that's the whole reason why we have the success criteria, because it anchors the learning around the success criteria, and it allows you to use that as a way to measure everything. Equally with the stretch tasks, because the stretch tasks are essentially additional success criteria. And whilst the success criteria is the sort of the core learning journey, the stretch tasks allow further learning to be done, and equally further assessment. So for the students that do whiz ahead, you can do additional assessment and to see to what extent they've enhanced their learning as part of that journey. Another way to use summative assessment is this idea of the elevator pitch, or like this Dragon's Den style presentation, if you will, where students at the end of a project have to present back to the group what they have come up with. And there's various different things you can assess this with. It could be about quality of communication. It could be about logical reasoning as they step through the code. It could be in their conciseness or their presentation. There's lots of different things that you could assess depending on which elements you want to focus on. For example, if you were doing project-based learning for business, it may be about how much detail can they pack into a 2-minute presentation and get the idea across about their project without necessarily getting lost in the detail or focusing on superficial features. Or for example, if you may want to focus it on the more technical aspects. So you could say to them, explain how you coded this particular solution and get them to do a presentation where they talk you through the code, explain the logic, explain the use of the different computational elements, and again constrain it with time so that they have to be able to talk through it in a not quick, but in a way which is concise. And you can assess all of these things using a fairly simplistic rubric. And you can ultimately, it doesn't need to involve the learner at all. You could take their artifact and you could assess it against the success criteria quite directly. So to what extent does it meet the success criteria? Does the, without even speaking to the students, you could see that based upon their product. And without the students there to defend their artifact, you can have a very, very fair assessment of the group's work simply by seeing what the output of that artifact is and whether it meets the success criteria. But that does lose some of the nuance, it doesn't necessarily assess, like for example, the learner's communication or collaboration. It's more just what the output is. And so an awful lot can be lost if you use that as the only way to assess projects. And whilst that is probably the most valid way to assess the outcome of this, it is very much differentiation by outcome and assessment of outcome. So you do lose an awful lot there. And another way to look at this is code reviews, as mentioned before. It's getting them to focus specifically on the subject that you're trying to assess for is a useful tool. And with digital and physical computing projects, going through the code is obviously a useful tool. So learning outcomes. Now, we've been speaking about success criteria for a few minutes, and so hopefully we all understand how success criteria are applied to these projects. And these are effectively our learning outcomes for these projects. And when you're writing your own learning outcomes for your own projects, it's really important to make sure that you use these and craft these in a way which sets expectations, fully present in the understanding that these are going to be used to assess your learners. So don't make the success criteria too trivial. Think about, when you're writing success criteria, that these are assessment tools, and design them as such. They need to be transparent insofar as the students are going to be aware of them up front, and they need to be achievable in a way that students can understand what is expected of them, and they are given the resources and the knowledge and the prerequisite knowledge in order to be able to achieve these outcomes. It needs to be measurable in some way, and that is where the projects can be really interesting, because you can measure it in lots of different ways. It could be they have to produce movement or a particular pattern of LEDs, or it could be a noise or something like that with a physical project and a physical computing project. So it's useful to, when you're thinking about the success criteria or learning outcomes, that how are these going to be measurable, and how will that feed into the way that you assess it. It's really helpful if you think of these as being consistent as well, because if you're having multiple projects across a curriculum, consistency of assessment is useful, because it allows you to revisit or remeasure a student's outcomes across time, and it allows you to see how they've developed. For example, if the solution to a particular problem involves using variables, and you may measure this in the first project, and they may not do particularly well. They may not implement enough variables or any variables, or they may misuse them. And then if you require in the success criteria later in a further projects, maybe several terms or weeks later, that they need to use variables, and then they do better, they re-implement it, you can demonstrate impact, you can demonstrate efficacy of teaching and learning. And so having consistency across your assessments is really useful. And one useful thing around physical computing in particular is that typically computer science and IT curriculum will be it'll be fixed around the computational constructs, things like variables, functions, selection, iteration, logic, those sorts of things. And so all of these elements are going to appear in all computer science physical computing projects to varying degrees, and so you can design your success criteria to require more of these as you go through a particular set of projects, so that the expectation of students is that they demonstrate them more and more in more and more complex iterations. And so that allows you to ably demonstrate that students have learned and applied these skills in a meaningful way, and again, that builds resilience and confidence in applying computational thinking to these problem-solving activities, and it should be relatively easy to measure, especially if you're looking at formal outcomes of the artifact, and measuring to what extent the students have met the success criteria with their project. Another interesting part about the way that the ARM School program schema is built is that the notion of self-assessment is baked into the journey. They have to work through an iterative development cycle to improve their projects, and by adding features and by limiting resources, they need to reflect upon what they're doing, self-assess and improve their project as they work through it, particularly on the larger projects. And equally and likewise, reflection is a key part of the schema itself. The final thoughts, the reflective exercise at the end of the project is a key part of the learning, as it makes students think back about what they've covered, think about the abstract concepts that were introduced at the beginning of the project, and how they've made them concrete through their practice, through the creation of their artifact. And also using the stretch tasks to really kind of layer on that learning. And as I mentioned previously, the stretch tasks are effectively additional success criteria, and allows the students the opportunity to demonstrate their ability even more thoroughly. So let's have a look at an example of this project. I've mentioned sort of success criteria in the abstract previously, but let's have a look at an example of this. So this, if you've been listening to these projects previously, you'll be familiar with this problem set. It is the micro-pet. So we have the context there on the left, which is setting the scene, and so students are tasked with creating an interactive toy, and then we have the success criteria. And this is a good example of a fairly simple project. And this is obviously aimed at fairly young learners, and you can see there that we have these relatively open-ended but measurable goals there, and you can stretch this task in a number of different ways, especially around the number of interactions that is expected of the learners. But this is a good concrete example of how success criteria are crafted, and how you can use these to assess a learner's progress through it when they make it. Another useful link when thinking about assessing computational thinking in learning is this idea of decomposition and the extent to which a student can progress through this decomposition process. And you can get a fairly good understanding of the extent to which students have gone through this simply by talking to them. So the students are given the problem set, so the success criteria, which we've just had a look at an example of. They then will be expected to break that down into a series of steps. And that very first challenge is you can ask them directly. You can say, so you have to make this toy interactive. What does that mean to you? What does interactive mean to you? And then they will have to think about and explain what that means. And then they have to go into problem solving mode. So I want to make it so that when you shake it, it's sad. So how do we do that? They have to think about the inputs and the processes and the outputs. They have to think about what digital tools are on the hardware that they're using, and then they have to think about and design a solution for that. And so by questioning them and by getting them to explain their thinking, you can see at which point on this sort of decomposition scale they are at, all the way through to them coming up with a design for a solution and implementing it, and then realizing it doesn't work, or it does work, and then they are successful, or they have to then iterate on their development and problem solve, and come out with a solution that actually does meet the success criteria. And you can kind of interrogate this process at any point, because you can observe them going through this as they're trying to solve a problem. You can observe them enhancing their solution in code, and seeing how different interactions on the PEP impact each other, which they do, and also seeing how that they troubleshoot that. And also, if they've already designed and developed and iterated on a solution, you can always just simply ask them to explain it to you. And again, relying on the project manager or whoever's doing the coding to do that, to either interrogate the group or the individual. And this also links through to the notion of the iterative development cycle, and how this should be really drilled into your students as a way to plan and design and develop all of their interactions. And this allows us to assess to the extent to which they are reflecting on their practices, and the extent to which they are aware of how they are meeting the success criteria and to what extent they're meeting the success criteria. And it allows you to kind of see in real time their computational thinking skills and knowledge and understanding been applied in a real and impactful way. So just to sort of refresh your knowledge of this, if you've missed any of the previous sessions, is this idea of giving them a success criteria, which we've seen an example of, the extent to which they design and plan a solution to that. Now, that could be a formal plan. You could get them to initially draw things out. They could draw flowcharts. They could draw IPO tables, and think really in a detailed way about the features that their artifacts will have and the types of code constructs that were used to develop this. And then you could assess at that point as well. You could just mark their plans, or you could compare their plans to their final output, and you could compare how their plans can compare to their final output in terms of how did they change. You could ask them to explain to them what did they change from their original plans to their final product, so that they have to explain their iteration. And then there's the development bit of it. They obviously then have to turn their ideas and their plans into a physical artifact, and then you can watch them do this and get them to explain what they're doing as they're doing it. And then the testing and remedial action, this is a real goldmine of assessment, because you can see any mistakes that they've made. You can see them, and that will tell you something about their initial take on it, because obviously if they're having to instantiate remedial action, then something's gone wrong. So there's been some sort of misconceptions and misunderstanding, either around the physical nature of the artifact itself or the development board, or a misunderstanding of the computational construct that they're trying to apply to solve the problem. So this is a really important step, because you can watch them again in real time solving the problem, and then again there are ways of allowing you to assess that and measure impact. And then the evaluation bit of it, all the students looking at what they've done and comparing it to the success criteria. Are they, are they learning? Are they progressing? Are they moving forward? And whilst they might do this in isolation in a single project, you can look at this over time, over several projects, and you can see them becoming better at applying this iterative development cycle and also being more effective at doing so. And also seeing how they're not making the same mistakes. They're applying the computational constructs with more confidence, with more resilience, and solving more complex tasks in a quicker way. And that's the beauty of this, is that you can look at it on the micro or the macro level, and it's still a really effective tool to assess progress and impact of teaching and learning. So that's the sort of the hard computational element of assessment. We also have to think about how can we assess soft skills, and this is, as I've mentioned in previous presentations, soft skills are one of the core pillars of the project-based learning approach, and we should be looking out for and assessing all of these different elements. As being, in group work, we expect students to be thinking critically, to be problem solvers, to be able to collaborate with each other, communicate with each other effectively, be creative in how they solve these problems. And so creativity and the critical thinking kind of overlap quite nicely, and they have to demonstrate character and citizenship in how they communicate and how they collaborate. So whilst these are all sort of
Now it looks like we've lost the audio there for a moment. Please bear with me a second.
sort of wonderful
There we
concepts, and they're all part of group working and teamwork and collaboration. We need a way to measure them, and that it can be quite tricky. You can get them to explain in a sort of a summative fashion, to what extent did you collaborate with your group, or explain a time when you were creative, or and that sort of thing. But that is fairly subjective, and it's more useful to be able to measure these things through direct observation or through peer assessment. And so you may want to come up with a rubric to assess these sorts of things, maybe a sort of a score out of 5 or out of 3, or maybe even have some descriptors which you come up with, which align to your particular curriculum or subject or formal curriculum that you're trying to follow, so that students can kind of tick off once they've observed, or the teacher has ticked off when they've seen these particular skills or facets in the group work. And it's really a matter of depth, because just by doing project-based learning, they will be demonstrating all of these to an extent. It's that what's the kind of the upper bound and what's the lower bound, and how do you want to measure it? So it's quite difficult to measure, especially in a sort of in a formal way. And I wouldn't advocate for assessing the 6 C's in a summative fashion, because that's quite difficult and is not particularly valid. But these are useful to have a way of measuring through observation, and as a way of sort of demonstrating how particular students or particular groups work together. And again, it's a really useful way to see how students are progressing and learning. And naturally, as students work more with each other, they will become better at communicating and collaborating. And you may find that different social groups work in different ways and at different paces. And yes, being able to assess it is quite useful. So we touched upon open questioning previously, and I just want to spend a little bit more time kind of unpicking that, because this is probably the most powerful tool when assessing project-based learning, because you as the teacher, you're in the room, the students are all in their groups, they're busily coding or building or making their artifacts, and you need to be spending your time going around and asking open questions to try and interrogate the students so that you're confident that they understand what they're doing. And you can use this as a tool to motivate and engage students. If a student is becoming disengaged, go and quiz them. Go and ask them, can you explain what's going on here? Make them the project manager, for example. And really, open questioning, it's it's a classic teacher tool, but it's just a type of question that can't be answered with a yes or a no. So explain what this bit of code does. Explain to me why you've built it in this particular way. Explain to me why what this branding for your product means. What does it represent? What does it say to you? These sorts of questions, you can get them to, and if they do answer in sort of one-word answers, then dig a little deeper and try to get them to explain in their own words what that means. And that allows you to have sort of a window into their understanding, and also to what extent they've thought about problem solving and applying their critical thinking skills, particularly around the sort of the computational elements, which is relatively easy to assess using open questions, because typically they either can or they can't explain to you what is going on, and if they can't, then clearly they had a little hand in formulating the solution. So it's a really, really useful tool, and it's one that I employ when doing project-based learning a lot in a lesson, and I'll try and ask open questions to every learner throughout the course of a project to make sure that you're assessing progress one way or another. And so this should be used in conjunction with the other assessment tools to make sure that everybody's on their toes whilst they're working on this sort of stuff. There should never be a point where a student is sat idle, and if they are, then you need to be intervening. Now, there are some issues when assessing group work, and it's one of scale, really. Typically, you'll have one teacher in a classroom with lots of groups, and you can't watch all the groups all the time. And even if you are watching an individual group, there may be 4 learners, you can't be assessing all of them all at once. And if you're using other sort of less direct measurement tools, individuals will always have different ratios of input into the artifact or the solution which is being developed, and you'll typically see this with driver students, or the typical extrovert, motivated, highly engaged student, which may be really confident in their problem solving skills and will carry the rest of the group, and that can sometimes disengage other learners. And so this is a pedagogical practice as much as an assessment problem, and making sure that all students are engaged and working towards the solution, and just be mindful of driver students when assessing, because the risk is that because of this one student overperforming, for example, the other students may suffer in their assessment outcomes through no fault of their own, and so this is something that you can again use open questions for the other group members to incentivize them to work more collaboratively with their peers. Another element is that learners, if they do engage and you're using a sort of a rather blunt tool of measuring the artifacts, if a student is disengaged, they may have a higher score because the other learners have carried them. So it's useful to make sure that all students are engaged all the time, because the more you let the groups steer or rather shape the work, or the less that involved all learners are, the more that will make the assessments less valid. There's also a danger which we see an awful lot when students are first engaging in project-based learning, in that they all take a specific role. You'll have the one that likes to do the colouring in, for example. You'll have the one that likes to do the marketing. You'll have one that just likes to do the coding, and the other one that likes to do the gluing and sticking. And none of them want to kind of cross over and do the other roles. And so it's difficult to assess all of the group for their coding ability if only one of them has done it. And so this is where, again, the project manager role can come in useful, and it's also useful to switch around the roles and make sure that all students are having a go at solving the problem. For example, if you've got a group of, if students are in 4s, for example, and they're making a micropet, make the success criteria, they have to create 4 interactions, and each member of the group needs to program one of those interactions. That's not to say that they can't collaborate and help to design those interactions, but each of the students needs to have a hand in creating that solution, and that's a really good way of shaping sort of the dynamic of the group and making sure that everybody can be assessed on the collective outcomes, because they've all played a part in all of them. And so it's just something to be mindful of, is that some students can drive ahead and make the group looks like it's been more effective than it was. It's so these types of assessments or group work is certainly more suited to to formative assessment, as I mentioned before, because the summative assessments can be not a particularly valid method of doing it, but using summative assessment on project-based learning, it does lose that nuance, and it doesn't always capture the whole learning journey, which formative assessment is much better at capturing. And so just bear that in mind, is that this isn't all about kind of hard A, B's and C's in terms of grades. There's an awful lot going on under the hood with this, and equally we can't rely on students to just do self-reflection, because I think the sort of there's a tendency or a want to just get the students to reflect themselves, or just write a short answer about what did you learn during this, and that can be seen as a sort of a quite easy thing to do. But we need to be clever in how we assess project-based learning. We have to utilize all these different elements of some summative, some formative, some peer, some self-reflection, and then all of that should come together to form a picture of what the students have done throughout their projects, and not rely on one methodology too much, particularly the sort of the summative assessments, because that is probably the least valuable out of the lot, depending on what you're trying to get out of it and what you're trying to assess. So let's have a look at the MCQs, which you mentioned earlier, and look at how these can be a useful way to do a summative assessment. They can be used for formative assessments as well. They could be used at the end of a lesson, for example, but these lend themselves quite nicely to summative assessments. So a structure of an MCQ is relatively straightforward, and I'm sure everybody's familiar with it, but you will have a stem at the beginning, which is the actual question bit of it, and these should be nice and short and simple. Simpler is better with these types of questions. And it needs to be concise and very, very clear about what is it asking for. So obviously this one is, what does IDE stand for? And this is in the context of computer science, obviously, so it's an acronym. You will then have several answers. It's good practice to have more than 3, but in this example we have 3, and you have 2 distractors, which are the wrong answers, and then you'll have the actual correct answer. In this case, it's B. So to create good distractors is very difficult, and I cannot stress that enough. What makes poor quality MCQs is having bad distractors, or not having enough distractors, or having distractors which are formatted in a non-useful way. For example, if you've got a set of distractors which are all completely nonsense, or obviously incorrect, or don't answer the question at all, which you often see, that can be quite easy to determine just through reductive reasoning what the real answer is. Just a good distractor is one which is believable, one that could be the real answer, or close enough to being the real answer, and so that it really does involve the student understanding and knowing the real answer to the question, and not being able to just guess. And it could be just as simple as such a thing as formatting. If, for example, if the wrong answers are all short and the right answer is long, or vice versa, that can indicate whether an answer is correct or not. So here's an example of an MCQ, and you can structure these to assess, what were the success criteria, what does this block of code do, does this block of code meet a success criteria, for example. So there's lots of ways you could use these to assess knowledge for the different projects. The issues with using multiple choice questions is that distractors are hard to write. As I mentioned, they can really give away the answers quite easily if they're poorly crafted, and they are probably, whilst the simplest type of question in terms of the structure of it, they are the most difficult to write. And anybody that's involved in formal assessment will attest to this, that writing good quality MCQs is really, really difficult. But there are some simple rules to follow around writing better MCQs, making sure that as I mentioned before, all the answers are of similar length, and that they're formatted in a similar way. There's no obviously wrong answers. Making sure that the distractors are believable. Not using negative stems, and I'll see this a lot in some formal certifications, sort of like, which of these is not correct, for example, and that's poor practice and shouldn't be done. And making sure that the stem is concise. It's oftentimes you will get long sentences for stems, and these need to be very short and to the point, and don't rely on the understanding of a particular word or verb or conception of an idea. You need to really make sure that the stem is assessing what you want it to assess. Otherwise, the item becomes invalid and just not a useful assessment tool. So that's MCQs. There is a better version of MCQs though, which we'll look at now. So a much more powerful type of MCQ is what's known as a diagnostic question. And you can see some really, really good examples of diagnostic questions on the website there, so diagnosticquestions.com, and there are examples for lots and lots of maths and computer science based questions there, and there's lots of ARM score program questions in there in a collection which we did in collaboration with Computing at School over in the UK. And what this does is they're structured exactly the same as MCQs, as multiple choice questions. The difference is that all of the distractors are designed to uncover a misconception. So there's the correct answer, and then the other three have been chosen for something which the teacher has has either seen in students in the past or is aware is a common misconception around that particular topic or concept. And that way, that if they get the questions wrong, it tells you something about what they understand or don't understand. And that is really, really useful, because rather than them just getting it wrong and that's the end of it, it allows you to unpick their misunderstanding and then teach them the right thing following that up. So it's a much more sophisticated assessment tool. And if you want to see some really good examples of that, then again, check out Diagnostic Questions for computer science and for maths, and there's some fantastic work there, and they can be used to link to formal curricula. For example, on Diagnostic Questions, there's lots of questions aligned there to the UK GCSE, and you can create these as well to be useful in whichever curriculum you are following. So let's look at authentication. So this is a sort of taking a step back out of assessment and looking more about how can we be sure that learners are or what the learners are demonstrating is actually what they understand. And this could be applied to sort of formal exams, but also into project-based learning and formative assessment. And this is where the idea of monitoring over time comes from. And it's this idea of validity in assessment. So thinking about, does what the learners are demonstrating match their usual performance? And this is not to say that if a student suddenly starts overperforming, that's a bad thing, because project-based learning can often bring out the best in students, and sometimes disengaged students will really start to flourish and shine in project-based learning. But is that consistent over time? Does the learner demonstrate the sort of thing consistently? Because if they don't, then you can maybe ask questions as to whether the student's work is authentic. Have they gone and then copied this off another group or another learner? Is it in a similar style? This is something we need to think about for all assessments. Is it authentic? Is the work that the students are presenting their own, and is it a actual realistic measurement of their understanding or knowledge? It's also worth thinking about if their style is changing over time. Is it changing in a style which you've taught them, or is it perhaps something they may have copied off the internet? And we certainly see examples of this with with tools like ChatGPT, which are appearing online, where students can now very, very easily apply AI to solve their problems, and they could just copy and paste a question into a browser and get a very sophisticated answer back very, very quickly. And this is a problem which is appearing a lot in universities and colleges at the moment, is that the AI is doing the answering rather than the learner. So we have to think about ways which we can minimize that risk and ensure that students aren't suddenly passing with flying colors when really they all have done is copied and pasted. If you're interested in sort of validity and authenticity, there's a really good book there at the bottom by an ex-colleague of mine, which is the kind of the Bible, I suppose, of assessment and validity. So do check that out if you're interested. So another thing we need to consider around validity and authentication is this idea of monitoring over time. So this is the monitoring of progression, and you have to think about this from a couple of different lenses. One of them is that it allows you to measure your impact as a teacher, so it's that sort of assessment of learning, and it also allows you to see whether your teaching practice is effective, and it allows you to measure similar things over time. So as I mentioned before, the idea of measuring, for example, the use of variables, it allows you to see students increasing their sophistication, their application, and their knowledge of applying particular concepts over and over again, and it hopefully increasing in efficacy and complexity over time. And it allows you to record that chart of students understanding an application of these complex ideas in a more rigorous way over time. So it's useful to do these types of measurements and assessments, whichever you decide to do, in the same way consistently over time and basing it around the success criteria. And if you align these the success criteria in the ways that you assess to your formal curricula, be whatever subject or curriculum that you're measuring against, it allows you to have a useful measure and demonstrate the impact of your teaching as well as the students' learning. And ultimately, what we want to see is students demonstrating their prowess, I suppose, in your subject increasing over time because of the impact of the pedagogy of project-based learning and because of your teaching. And last but not least is the idea of providing feedback. Now, this is often seen as very, very time consuming, which it can be. But feedback is an essential part of learners reflecting on their progress. And this can be something as quick as when you're asking them questions, when you're using open questioning, is giving them feedback, saying to them, this could have been improved, you missed this, what can you do to improve this for later? So it's useful to categorize your feedback around what you're assessing for. So, for example, basing your feedback around the success criteria and saying, you didn't quite do this success criteria and you could have done X, Y, and Z. And you shouldn't use comment banks for feedback as well. I'm sure we've all seen comment banks as part of some assessment tools, because they're very, very impersonal and it's really, really poor practice. But it's useful to think about feedback of answering these questions. What can the student do? What can't they do? How does it compare to others, and how can the student do better? So how can they improve? Now, be careful with the third one there around students comparing to that of others, because that can obviously that should be used so that it doesn't disengage and disenfranchise learners. And obviously you don't want to be comparing weak students to particularly strong students. It can be a good motivator, but just be careful not to put your students off by demotivating them. But ultimately, feedback should be educative in terms of it should give them something that they can aim for and can improve upon. You should do it as quickly as you can to what you observed. So doing it the next lesson or immediately is really, really useful. And again, through that use of open questioning and giving them feedback on their answers, and ultimately being sensitive to the user's needs. Giving feedback should always be positive. It should be constructive, and even if you're saying things that they should improve upon, you should do this in a sensitive way, and using it as a positive experience for all, so that they engage more fully with the learning experience. So that is everything I wanted to cover in today's topic. Obviously, this was a bit of a whistle-stop tour about assessment and some of the more technical and esoteric elements of assessment. I hope this was useful and it made you think about assessment in project-based learning in a new way. And we'll now move on to the Q&A. So thank you very much for listening, and please do check out our other broadcasts in collaboration with CBSE around project-based learning and physical computing. Thank you very much.
Oh, that's excellent. Thank you very much, Rob. That was a great session. So before we actually move on to Q&A, and we've got a few questions that have come in, I'd like to hand over to our colleague Surya, who'd like to tell you a bit about the feedback form, and we'd love to hear your comments on today's webinar. Over to you, Surya.
Today's session, I have shared feedback form link in the chat window. I request all the participants to give your valuable feedback over there.
Surya, could you just repeat that, because I think we missed the beginning of your sentence there.
Dear participants, I have shared the feedback form link in the chat window. I request you to give your valuable feedback over there.
Great, thank you. Yes, so if it wasn't coming across clearly to me, if you missed that, Surya has put the feedback form link to it in the webinar chat. So please do click on that. It just takes a minute to complete, no more than that. And we would love to hear your thoughts on it. As I mentioned at the beginning of the session, just to reiterate that you will receive the certificate of attendance for this session along with a link to the slides for this deck, and along with a link to the recording of the presentation after the session. So within the next week or so, that will arrive with you. So please do sit tight. That's how you receive your certificate. Okay, let's move on to Q&A, and we're joined by Rob. And as I mentioned at the beginning of the session, Rob, this topic is a particular passion for Rob, because he's got a background in not only in teaching of computing, but also curriculum development and assessment. Rob, can we just check that we can hear you on the audio?
Hello, Nick. Great
Oh,
to
there
be
we
here.
are. Excellent. Super. Great stuff. Okay, so 3 questions that we've got. The first one, I think, is quite a really interesting one when we reflect on how the position of PBL within education and within the curriculum. So a couple of comments that you made within the session. One was, and I thought the slide pointing out the issues to do with assessing project-based learning was really interesting. One of the points was that summative assessment is difficult to make valid with PBL. And also you mentioned that PBL isn't all about maximizing exam grades, which sort of, the two things support each other really. And I just, the question here is about, some high stakes assessment include a project element, but many don't. Now, if they don't, how does PBL fit into the curriculum? From a teacher's perspective, how do you perhaps justify it? And what are you preparing the learner for if it isn't the skills in those high stake assessments at the age of sort of 16 or 18?
Good question. So, as we've covered in some of the previous sessions, the whole point of project-based learning is it's not preparing them for sort of a direct attack on the exam process. It's about building confidence in the learner's ability to be able to apply complex and interrelated subjects in a confident and resilient way. And you see this throughout all the examples that we give of the computing projects that we look at, where whilst an exam on paper may be about looking through code or be answering questions regarding code, them applying it in real life to solve a real problem it's a different way of learning, but it makes them apply the different techniques and practices that we're trying to teach them in a way that solves a problem, which is much more useful. And there's research done recently. I remember seeing this from Cambridge Assessment that learning something by doing is up to 20 times more impactful than learning through rote. And that really says something, So learning to code a solution to a problem and physically applying it in a project is a lot more impactful than just learning it off the board, should we say. And really that's the point of all of this, is that they will be given a novel problem. They have to solve it by applying the techniques we want them to learn, and then that will hopefully translate into them being able to answer exam questions more effectively. So it's a different way of attacking the problem of them understanding it, but it's much more effective in doing so, even though they may not be assessed formally in the same way that the project is run. And you mentioned that some projects and some courseworks do have a project element, but I think it's fair to say they are very different to project-based learning. I mean, they may be actively doing something, but they are constructed around being able to measure progress and being able to assess them in a particular way, which really colors what the project is and how it works and what it works. And you can't do them in groups, for example, which is a big part of PBL because of the validity issues that I mentioned before. So yes, I think they are subtly different, but a sort of a vehicle for learning, PBL is incredibly effective, and I think whilst there's not a lot of formal research into the sort of the effectiveness of PBL compared to exams, because that's obviously would involve quite a big study, everybody that uses PBL, certainly that I speak to, says that it is very, very impactful, and students come away from using PBL as a teaching tool. Students come away from it much more confident in being able to problem solve using code, and that's really what we want. We want them to be able to solve problems confidently.
Oh, it's really interesting. So what you're saying there is that when it comes to those high stakes assessments where the students may be sitting down with a printed exam paper, for example, then the sort of skills that the students can pick up through engagement with PBL, like resilience, like the ability to deal with the unknown, the unfamiliar, problem solving. All of those things come to bear in those exam scenarios. So there really is a place for it within, from that perspective, if we look at it from that angle.
Yeah, I think there's a tendency when learning sort of code problems is that they learn it only in a particular context. They learn it, you know, what a loop is, or how to apply a certain variable, or how to do a bit of iteration, and sort of anything outside of that very constrained context it's difficult to apply it in different and in different ways, and that's can be quite unnerving for students when they're given an exam question which is something totally different or framed in a different way, whilst in PBL you're expecting them to apply these abstract concepts in lots and lots of ways iteratively, so they're having to revisit these different bits of knowledge and different techniques in lots of different ways across different projects. So they're practicing using these techniques an awful lot, and that makes them just better coders, and therefore when they do hit the exams they're going to be much better prepared to do well.
Great. Okay, so two other questions. I'm going to skip to the last one because I think it relates to these kind of themes about how it fits into the broader school experience. How important is it to bring your colleagues, your school, your senior management along with you if you're, as a teacher, interested in introducing PBL into lessons, and how do you do it? And I think these themes are picked up in course 4 of our edX program, but I wonder, Rob, if you could kind of reflect on that, particularly thinking about the kind of perhaps resistance that you might initially get from some colleagues who may be unfamiliar with the practice.
Yeah, the notion of project-based learning comes with some baggage in different subjects. And certainly in the UK, project-based learning is a bit of a dirty word. Certainly in the design and technology space, where it was associated with the quite raw constructivist approach of just give them some work and expect them to learn by doing it with very little intervention. And I think it was applied very, very poorly. This was back in the 90s, and so I think there is a perception that it's not a very useful tool. But if we're using like the ASP schema, where we're structuring learning experiences with all of the tools that I've been describing over all of these webinars, it negates all of that, and in fact creates a really impactful learning mechanism. In terms of working with colleagues, I think that part of that is explaining to colleagues that may be dubious about the approach, and sort of consciousness raising with the colleagues as to what project-based learning is, because they may have assumptions, and it's a case of explaining to them that it's not just giving them a bit of hardware and expecting them to learn all about it by themselves. It's not like that. There is a lot more to it, and again, you could explore all of what PBL is and how certainly ASP explain and describe it, project-based learning through the courses. There's an awful lot to think about. It is a complex pedagogy, but it is obviously really, really impactful, and you have to be able to demonstrate to your colleagues the impact of that. And I think and I've had this with colleagues at ARM as well, where they think, oh, it sounds a little bit strange, but then when they see it in action, their minds are blown, and they see that the kids are really, really engaging with this sort of stuff, and they're really enjoying the learning. And I think it's one of those things of show them and then they'll get it, and then you can also explain all of the theoretical elements that sit underneath it and all the techniques and why those techniques are in place as you develop. But I think it's getting over that initial barrier of doubt, I suppose, is the hard bit. And also dealing with senior colleagues, it's about getting budget for these things, because certainly with physical computing, you need the physical devices themselves, be them microbits, Arduinos, Raspberry Pis, or whatever. You also need some, you might need some electronics, you might need some motors, so there is a cost element occasionally, depending on what project that you're doing. So it's you do need to get some buy-in from your colleagues, and you also might need some support initially when you're running these sorts of sessions. But they really do work, and if you're going for sort of long form projects as well, if you're doing this over a couple of lessons, that might involve some timetable changes, for example. So you will need to loop in your colleagues, but I'm yet to see colleagues in schools who have seen this when it's been done well, and then and haven't been convinced. It's obvious that it works when it's done correctly.
That's great. So third question, the last one, which I think picks up on both of those, the first two really, which is the experience for a teacher who is new to PBL and beginning to try to implement it. So the question is, it feels like from this session, and probably also from previous sessions as well, that actually there is a great deal of complexity to PBL, and it takes time and it takes practice, not only for the students but also for the teacher. So this is probably an impossible question to answer, but how long and what is that? What would you recommend as that process for kind of easing your way into these sorts of practices?
Well, PBL doesn't need to be terribly complicated. This is why we've created this schema, which I've talked about at length in other sessions, where as long as you follow the structure that of the resources, with the success criteria, by setting a context, by scaffolding the challenges effectively, that is it leans upon fairly standard teaching practices, and so you can implement it very, very easily, as long as that you maintain the sort of spirit of what project-based learning is about, and that's you enabling students to progress by giving them the tools and giving them something to actually aim for. So in terms of the assessment, giving them very, very clear success criteria, that is fundamental to get right. There is an awful lot of complexity that sits underneath it, and as to why we structure it in that way, why you should have good success criteria, why we scaffold things, why we have reflective exercises, all of the things that we've touched on across all of the presentations and courses that we've put together. So obviously there's a lot of complexity because we've got 4 courses and edX. There's a lot to dig into, but if you wanted to take this off the shelf using the ArmSchool program resources and apply it in your classroom now, you could, and you could do it successfully. And I've certainly seen volunteers at ARM who aren't even teachers going out and using the Microbit project just after 20 minutes of coaching from myself, and so they can go out and apply this effectively. They just have to understand what we're trying to do, and it's not about giving them the solutions, it's about giving them the tools and enabling them to work towards solving the problem and meeting that success criteria and assessing it, as we've talked about today.
Fantastic. That's great. Okay, so thank you, Rob. I think we've reached the last of the questions. We've got a few comments asking for the feedback form. The feedback form has been dropped into the webinar chat rather than the Q&A. So if you open the webinar chat in Zoom, the latest comment is from our colleague Surya, and it's a link to the feedback form that you can complete. It just takes a minute, and we'd love to get your thoughts. Okay, so I'd like to thank you for joining, and also before we close the session, to encourage you to pop this in your calendar. The next session, we've got Developing Employability Skills with Project-Based Learning and Physical Computing, 15th of March, same time. It's another Wednesday session. Please do pop it in your calendar, and we hope to see you at the next one. And it just really remains for me to thank again Rob for the excellent session today, and to thank CBSE, in particular Dr. Saha and Mr. RP Singh for the opportunity to collaborate with CBSE on this webinar series. If you are interested in the themes that we've covered within this session and previous ones, please do visit edX.org, search for Teaching with Physical Computing, and you can explore our 4 courses, which I talked about at the beginning of the presentation. It's free to access, and there's more detail and suggestions of how you can explore these topics from a practitioner's perspective. So please do dive in and log on to those courses. Okay, all that remains for me to say is thank you for joining us, and we hope to see you on March 15th. Thank you very much.